Hello everyone, welcome to this presentation. My name is Laurent Bugnion. I'm a cloud advocate working with Microsoft, and I've been working with .NET for about 20 years now. In fact, my very first project in .NET was in 2001, so it's been quite exactly 20 years. So I'm really excited to talk to you about .NET and to show you a little bit what is the state of .NET currently and also where .NET is going. We are going to have a few slides, but most importantly, we are really going to have a demo, and I'm going to show you how to build a Blazor application. This is a new way to build client-side applications with .NET, a Blazor application that we are going to connect to an Azure function. And very excitingly, we are going to also publish that to Azure using something called a static web application. This is a new way to host applications on Azure. And so we are going to leverage that for our needs. So let's talk a little bit about .NET first and about what is going on with .NET. So first of all, important to know there is general availability of .NET. This is since November 2020, November last year. And you can get .NET by going to .NET/get/.NET5. There are a lot of dot and net and, and get into that URL. But don't worry, because at the end, I'm going to give you a place where you can go and get the slides and you will have everything there. A few innovations which are interesting there. First of all, you can publish a .NET application as a single file application. And this is quite important. It makes things way easier if you want to, especially to publish things or to send something to a client or to a customer or to a user. Also, the container images are way smaller. They did a lot of investment in the web and the cloud. We'll talk about that a little bit later. Also, in terms of Windows desktop, the good old Windows Forms has been enhanced, as well as Windows Presentation Foundation. There is also support for Windows ARM64. This is quite modern and quite interesting here. And of course, always some performance improvements. Also, interestingly, new features in the languages. So C#9, F#5. If you're interested in those features, check the presentations next to that. And this is also interesting to know. And definitely something that you probably want to check out. So again, if you want to check where you can get .NET, you go to .NET/get-.NET5, and this is where you can download it. Okay, next thing we have is performance improvement. And performance improvements are tremendous. In fact, we have huge performance improvements, especially for communication and Json serialization. And so this is really important if you build APIs. And Json serialization, nowadays, everybody works with Json and everybody sends Json over the wire. So if you want to serialize and deserialize that, you want it to be fast, which is a good place to remind you that all I'm telling you works also on Linux. And this is important, especially if you do things on backend. For example, on Azure, you can totally host an Azure function on Linux if you prefer. And then you have advantages in terms of price and in terms of stability, etc. Not that Windows doesn't work. Windows works great, but really a lot of the web works on Linux these days. Also nicer on memory management. So if you do things like serialization of large collection of arrays, etc., this is going to work well. And also Grpc performance improvements. It must be noted that Grpc is a next generation of networking protocol. It is kind of the next step if you are using WCF now, Windows Communication Foundation. Moving to Grpc is probably a good idea. So also some big improvements in this area. Windows development, let's not forget Windows, because those who know me know that I love the backend now, but I started actually my career in client application development. I was an MVP in client application development for many years. And so I'm very happy to see improvements in WPF, but also we shouldn't forget Windows Forms. So if you do Windows Presentation Foundation, Windows Forms, then you're going to be happy to hear about that. First of all, improvements in the tooling. There is a new Click Once installer, new designers as well. So if you do UI, that's going to be interesting for you. There is also a self-contained exe. What it means is that everything you need, and in the past when you were creating a .NET application, you would have an exe and then you would have a lot of DLLs, and sometimes it's a little bit annoying. Now you can put everything into a self-contained exe and put that, send that to your customers or to your users. And also you don't need the .NET framework on the client. So this is quite important, because until now, every time that you wanted to install a .NET application, you had to download the .NET framework first. But now this is not needed anymore, because the .NET framework, everything which is needed for .NET to run, is contained into this self-contained exe. And so what it means is that if you need to have multiple versions of the .NET framework side by side, it's going to be no problem at all. What was before always a problem. A few other improvements: best performance, and also some controls. For example, WebView 2, which is a new version of the WebView, which allows you to do, hosted web pages inside a Windows application. Things that can be quite interesting if you do hybrid things. All right, moving on, let's talk about Xamarin, because Xamarin Forms is a way to develop applications, mobile applications, I should say, cross-platform mobile applications using .NET. And one thing you can do is that you can develop your application with a XAML front end and some .NET backend, and then after that you compile that to Android and to iOS, and then you have a cross-platform application. So you can indeed develop mobile applications with .NET. In fact, we have been doing that for many, many years now. And improvements in .NET 5 are things like new design elements. For example, you can do brushes. And for those of you who come, like me, from WPF, brushes are really a nice way to paint your UI elements. Also shapes and paths. And so you can create some icons and some shapes and things like that to enhance your UI if you want. Also control templating, and that was really something that we were expecting and we were waiting for, so that you can really template even native controls and gives them a different appearance. Things like XAML experience in Visual Studio has been enhanced, including hot reload, which means that if you do a UI in XAML in Android or iOS, you can then save, and then it's going to automatically reload on your target device. And this allows you to have I would say an application development loop, which is much faster and much better. You can also develop iOS applications on Windows. And so prior to that, you needed always a Mac on your network to even develop the application. Now you just need the Mac to actually do the last step, which is the publication of the application to the App Store. But you can actually run and develop at least your iOS applications on Windows, and then run them directly on an iPhone in order to test them. So that's quite interesting too. All right, so Visual Studio 2019, that's the current version of Visual Studio. And one thing which is important to know is that .NET 5.0 is included in Visual Studio 2019. So the last update that we have is version 19 of Visual Studio. So if you have that, you will have .NET 5.0. Also some productivity enhancement around, for example, IntelliCode. So now when you work with IntelliSense, it is much improved. You have also a new Git experience. So if you like to do Git directly in Visual Studio, you can do that. Note that there is also the possibility, of course, to work with a Git client, which is external. You can also do Linux debugging. And so if you have, VSL, WSL, the Windows subsystem for Linux, you can connect to that and debug your application as you are developing it on Windows. And also improved XAML experience, or designers, we talked about that earlier on, but also the possibility to manage and develop your GitHub Actions in Visual Studio. So for those of you who don't know, GitHub Actions are YAML files, which then you publish to GitHub. You just commit them into your repo, and then they are going to execute some actions. For example, they can, take an app service and deploy that to Azure, or they can take Azure functions and deploy that somewhere, etc., etc. Or they can just take your .NET package and build it and make a NuGet, maybe, and even publish it to NuGet. All kinds of actions you can do. Until now, you had to develop and maintain those outside of Visual Studio, for example, Visual Studio Code, etc. But now you can do those directly in Visual Studio, which is quite nice. All right, moving on to other improvements, cloud native investments, cloud native improvements around REST APIs, for example. Now we have full support for Open API. Some of you know Swagger, okay? This is something like that. Basically, it builds a documentation for your APIs, and like this, it's very nice because you can just navigate to a web page and then you will have the documentation of the API directly there. Also support for API REPL. This is read, eval, print, loop. It's a way to test a programming environment faster if you want. But also you can generate some clients for your REST API. So basically you say, all right, I want to point my .NET application to this API, and then it's going to generate everything you need for yourself, including a client. And it makes working with REST APIs easier. Also a way to publish API management, which is basically a way on Azure to manage and to maintain your REST API. So of course, first-class support, you would say, for APIs on Azure. So this is pretty good. But we also have improvements for gRPC, so contract-based APIs. In the contrary of REST APIs, which don't have a clear contract, gRPC have a contract. And so you can also generate a client and a server from a contract file, from a proto file. Also, of course, performance improvements, we mentioned that before. In terms of microservices, also a lot of improvements. We have smaller and faster microservices. The container images where you deploy your microservices are smaller. You can create single file applications, which are cool because you have everything contained into a single file, which makes the maintenance of those containers easier. And you can also have top-level C# program. And so you kind of avoid, this is a new feature of C# 9, where you can basically avoid a little bit some of the I would say some of the ceremony around C# programs where you always need to have, a namespace, and then you need to have the class, and then you have to have all kinds of things. Now you can build top-level C# program. If you're interested into that, check the newest additions in C# 9. Project Tie is another tooling improvement where we work with Project Tie to build, debug, and deploy microservices much more quickly than before. And this is really quite impressive. You can basically work with conventions, or you can also create a YAML-based settings file to build, debug, and deploy your microservices. Cross-platform development, we mentioned that before. .NET runs on Linux now, and so you can do cross-platform development with the Windows subsystem for Linux, WSL, and Linux itself, and also a reverse proxy, which has been added, which is great also for microservices. So if you're more interested into those topics, make sure to check them out. But now we come to kind of the meat of this presentation, if you want, Blazor. And why Blazor? Why do I put a lot of emphasis on Blazor? Well, I come from the client-side application development, but now I work with, Azure and Azure Functions, App Service, etc. And I feel that Blazor is really hitting a sweet spot, if you want. It is, if you run the WebAssembly, it is running in your web browser, but you don't need to write JavaScript, or you write, maybe just a little bit JavaScript, but really a minimum of that. Most of the code you write is going to be C#, and then you can use all the libraries you love to use via NuGet. So really, some really cool stuff happening there. And in the WebAssembly domain, we also have some enhancement. Now those WebAssembly Blazor applications use the .NET 5 core framework libraries, which are way faster than before, up to 3 times faster than previous releases. And you also if you do, server-side Blazor, we can also support server-side pre-rendering and loading dependencies in a lazy way, which is quite nice because like this, you minimize the size of the application which is running in the web browser. Component virtualizations, which is great for responsiveness if you have a list with a lot of elements, etc., etc. But basically, check it out because Blazor is growing to a point now where you also have an ecosystem of libraries and tools and controls from different vendors, which make life very, very much easier. And I would like to illustrate that, if you want, by a demo. And in this demo, what we are going to do is build a full-blown application. It's a very simple application, but still it has a client side and a server side. And then we'll deploy this application to Azure using static web apps. So stay tuned for the demo. All right, so for this demo, we are going to use Windows Terminal, and I'm going to use, in fact, the command prompt, but it's kind of nice to have it in Windows Terminal. So just start Windows Terminal on your machine, and then after that, open a command prompt, and I'm going to change to the desktop and create a new folder. In this folder, I'm going to type .NET new Blazor WASM. So this is Blazor WebAssembly. And I'm going to put the output into a folder that I'm going to name client with a capital C. And we'll understand later why this name. Then I type code dot, which is going to open Visual Studio Code inside the folders that I just created. And of course, the nice thing is that Visual Studio Code also runs on Linux and Windows and Mac. And so you can do that everywhere. Let's explore the application. This is a Blazor WebAssembly application. You see that it has some Razor pages, so it's HTML. But notice that the code here is actually in C#, which is quite interesting because it allows you to do code without having to type JavaScript. Now, I have a field which is called current count. And one of the very nice features of Blazor is that you can actually bind two fields. And so here I have a current count with an @ which is bound, data bound to this field. And so every time that I increment the current count, then the UI is going to be updated automatically, which is, of course, very convenient. So I'm going to change to the client, and now I'm going to run this Blazor application. This is just the default template. Let's do .NET watch run. Why do I do watch? It's because it's going to allow me to watch changes. And so every time I save something, I save a change, then the application is going to be reloaded automatically in the web browser, which is quite convenient. Here is the application. You see the navigation here. I can navigate to the counter, and then I'm going to click, and this is going to increment the counter. So that's just the default template. But now we can start making changes. For example, I can change the title. Let's set that to Future Tech. If I save, like I said, it's going to reload automatically in the web browser. It works exactly the same than before. We can then make changes to the code as well. For example, here I'm going to increment by 10 every time I click. It reloads automatically, and then click. It is still working. So that's pretty cool. So in terms of client, we have something, but now I would like to develop a server application for that. So I'm going to go into the terminal. I'm going to create a new tab, and then I'm just going to put some colors to make them easier to differentiate. So yellow is the server side. It's going to be an Azure function. So let's go also to the desktop. I'm going to change to the same folder. And now I'm going to use the function CLI, the function command line interaction, to create a new application, which is going to be hosted into the API folder. And I use --.NET, which is, of course, telling my function runtimes that I want to use .NET-based function application. All right, so now this is created. I can go back into Visual Studio Code, and now I see I have a new folder. And this time, this is a server-side application. So let's go into the Azure extension. You need to install that if you want to do Azure things into Visual Studio Code. You can install that directly from the extension tab. And then I'm going to go to the functions section here and create a new function. Using that, this is also going to allow you to publish your functions to Azure if you want. But here, in that case, we are not going to do that because we are going to use the static web app to host the function directly. So let's go and select a template. We have tons of templates. The one I want to use here is HTTP, meaning that it's going to be an HTTP API. But you can also do a timer, which is a recurring function. You can do blob triggers, which react when something changes in a blob, for example. So here, let's select, an HTTP trigger, and I'm going to call that get ticks. And so this is simply going to tell me, all right, the ticks on the computer that I'm deploying to, just so that I have something with changes. Later, of course, we can expand on that. Now, this function is going to be very, very simple. So I'm going to remove most everything, and I'm simply going to reply with 200 OK and the number of ticks on the server computer, so datetime.now.ticks. All right, now from here, we could test the application directly in Visual Studio Code. But here, what I'm going to do, I'm going to go back to my terminal, and then I'm going to go to the API folder and select func start. So now I have a function application which is starting straight on my computer, on my development computer. Note that this is exactly the same runtime than we have on Azure. So very, very convenient to use. And now you see that I have a URL, and this URL, I can click on it and open that in a web browser. And if I refresh, I see that the number keeps changing. So it is, in fact, the number of ticks that we have on the server computer. Let's copy this URL because I'm going to need it later. Now I'm going to go back into Blazor, and I'm going to implement a call to this application. Right now, everything is running on my development computer. So if I go into increment count, first of all, I want some ticks, and ticks are the type long. So if you want to avoid an overflow when I parse the long, then I'm going to change here the count to long. Then after that, this is going to be an asynchronous call. And so, of course, the huge advantage in .NET is that we have async and await. And so I can use here an asynchronous method, And then what I'm going to do is that I'm going to create an HTTP client. And then using this HTTP client, I'm going to call the function. And so I'm going to call await client.getAsync. And then I'm going to paste the URL that I copied before. Once I have that, I'm going to then try to parse the number of ticks, and then I'm going to assign that to the current count. Now, one advantage of using .NET here over JavaScript is that you see I made a mistake. I chose getAsync instead of getStringAsync, which means that what I'm getting is not something that I can parse. It's not a string, all right? This is going to be actually an HTTP response. But the good thing is that the compiler warns me here and tells me, careful, I think you did something wrong. And this is in fact correct. I did something wrong. So I'm going to go and fix my error before I deploy, before I test, which is of course a huge advantage of having a strict language here, even on the client. So I'm going to select get string async, and now suddenly all my problems are gone, and I can build and deploy that and try it out. Now, in fact, I don't even need to build and deploy because remember I have .NET Watch run. And so this is actually already running. But one thing I need to do on my function side, because I'm going to call a function from my Blazor application, those two right now are not running on the same domain. And this is going to be a problem because, of course, the functions are protected with CORS, with cross-origin. And then I need to deactivate that temporarily. So I'm going to go into the local settings. This is only for my local application here. This is not published to GitHub or published to Azure. And I'm going to specify that I want to allow other domains to access this function. Because I did that change to the settings, I need to quickly restart my function application. So let's do that. All right, it's just going to take a second. Now it is back, and this time ready to accept requests from another domain. And so I can go back into my Blazor application. Remember that it's still running and it has been rebuilt when I saved. And now if I click, I have a small delay because this time it's asynchronous, and then you see the ticks appearing. So everything is running great. This is local on my machine, but now we are getting ready to deploy that to Azure. All right, so for the next step of the demo, we are going to go back to Visual Studio Code. Remember that I have my client application and I have also my server application. And now I'm going to deploy that to Azure, but I'm going to let everything run on a static web app. So what it means is that I'm not going to use localhost anymore. I'm going to use an API which is located, in fact, in the same domain. Now, this is something that you can set up by using a different app settings file when you develop compared to when you deploy. It's what I recommend to do. But here for the demo, I'm going to simply hard code this. And what I'm going to do, I'm going to go into the program.cs, which is like the entry point of the Blazor application. And I'm going to create a new HTTP client, which then I'm going to use into, I'm going to add it to the dependency injection system. So it's going to make my life way easier because I don't need to maintain the life of this client. And notice here that I have the base address, which is set to the base address of the Blazor application. Because the Azure function is going to run also in the Azure Static Web Apps, they are going to have the same base address. And then you don't have the problem with CORS that I had before. Remember that the change I made to CORS is only for local development. On Azure, my functions are going to be protected by CORS, and nobody can access them if they are not on the same domain. All right, so now I'm going to go back to my page, and I'm going to inject the HTTP client I just created into the page by using @inject. So as you can see, this is very easy to do dependency injection in Blazor, just like in fact in ASP.NET. And I'm going to call that HTTP. And then instead of using an HTTP client that I'm creating from scratch, I'm just going to use this injected client, which is also better for performance in your application. So now I can remove the qualifier, the top level domain if you want, because I'm going to use the base address, which I define in the HTTP client. So now let's go into our folder, and I'm going to put everything into GitHub. I prepared the git ignore file. I'm going to add this into the folder. And then you can use whatever client you prefer. For me, I like Git extensions. It's something which is quite nice to use in Windows Explorer. And I'm going to create a new repository inside this folder. And then I'm going to open this repository. And I'm going to go and push everything to GitHub into a new repo that I'm going to create in just a moment. So now I have everything ready. I'm going to commit everything, so I can take everything I need. Because I have the git ignore file, this has been optimized. I'm going to enter a commit message, ready to deploy. And then I'm going to commit that locally at first. And then I'm going to get ready in order to publish that into a repository. Let's just rename the branch because we prefer main. So let's go into GitHub and create a new repo. And this repo is going to be totally public. It's in fact the one that you can access at the end of this presentation. I give you the link to that in the last slide. And we create the repository. And then after that, we are going to copy the URL of this repo. So I can create a new remote. I'm going to call that origin. And then I'm going to put the URL to this repo there. Let's save that. And then we can configure everything locally. It's just going to take a second. And then we can push everything to GitHub. So as you can see, very convenient way to work. But of course, like I said, you can use absolutely any Git client that you prefer. And we push to GitHub because we are going to use GitHub Actions to publish to static web apps. So it makes sense in this case. All right, everything is up into GitHub. We can go and refresh the GitHub repository and see that we have our codes there. So now let's go into Azure, and we're going to create a new Azure Static Web App. Static Web App, it's a new offering that we have. In fact, it is still in preview, but it is very stable, and I recommend that you try it out. Since it's a preview, product that we have, of course, be careful if you use that in production. But I use that in production for a few utilities that I have, and it works really great. All right, let's enter a name and a region for that. And then we are going to publish that using GitHub, so directly from the repo. So I'm going to go here and get access, or rather provide access to the Azure Static Web App from my repo. Then after that, I can go and select the organization I belong to, the repository that I want to publish. It's Future Tech 21. And then I'm going to select the branch. Right now, I only have one branch. Okay, we are publishing a static web app, but we have different frameworks that you can use. JavaScript frameworks, static site generators such as Gatsby, Hugo, etc., ViewPress. Here in that case, we are going to use Blazor. Like this, we have everything which is set up to build our .NET application using the GitHub action. Now, this is a point where you see why I created those folders, client, API, and WW root. Client and API are kind of default names for the client and for the API. Of course, if you decide to select another name when you create the Blazor application and the Azure function, you can change that here and make sure that it is matching. All right, so here I have everything I need. I can go and create this Azure Static Web App. And will just take a few seconds. It is actually real time. I didn't speed things up here in the demo. Then I can go and check this website. So you see I have the URL. It means that the website is configured, but nothing has been loaded yet. And this is because if I go back into GitHub, into my actions in the same repo, now I see that there is something happening. And what is happening is that my changes are built automatically by the by the GitHub action, and then they will be pushed to Azure Static Web App. So this is really cool because you can monitor your changes. You can say, I want to change things only when there is a pull request, or I want to change things every time that somebody commits to main, or you can watch a specific branch or a specific folder, but by default, everything is going to be observed automatically. So now this is done, we can go back to our website, we can refresh, and now we see our Blazor application has been deployed. This is cool, but even better, the API, the function application, has also been deployed to Azure and is also running in the static web app environment. So if I click here, we see these ticks number, but this time those tick number come from the Azure server, which is pretty cool. So hopefully you see the advantage of using this pipeline, automated pipeline, to create your application, test your application locally, deploy everything to Azure every time that you commit, and then you can even have staging environments, etc., etc. So this is really cool. All right, so hopefully you like this demo. I think that it's an interesting topic, and of course you can get access to the GitHub repo, and everything you need is in the last slide, so don't worry about it. You can get access to the GitHub repo and try it out by yourself. All you need is going to be an Azure subscription, but you can totally do an Azure trial subscription, which is free, and then you can try it out by yourself and deploy, just do a fork of the repo, deploy that to your static web app, and then start modifying your Blazor application. So hopefully this should be fun. So in order to continue here, let's talk a little bit about the schedule of .NET. .NET 5 is released. It was released in November last year, 2020. But now we are also planning major releases to .NET every year and always in November. Now, note that we will have long-term support, LTS, long-term support for even-numbered releases. And why don't we have long-term support for every version? Well, basically, first of all, it's to also to optimize the support. But one thing which is cool is that if you do .NET 5 right now, and then next year, or rather this year, 2021, in November, we release .NET 6.0, and we have a LTS, a long-term support, we also guarantee that the upgrading from .NET 5 to .NET 6 is going to be very easy. So it's a very predictable schedule. Of course, you will have some minor releases, so 5.1, 5.2, etc., as needed. For example, if we need to fix something urgently, but you can always count that you will have a new major version of .NET every time in November. And so stay tuned. November 2021, we'll have, of course, .NET Conf, which is traditionally the conference in which we announce the new version of .NET. So quite interesting here. So I have some resources for you. First of all, .NET 5, the general availability, like I mentioned, you can get it now, and you will go to .NET/get-.NET 5, and it is also available if you go in Visual Studio 2019 from update 16.8. If you have a newer version than that, then you can have access to .NET 5, which is directly installed in Visual Studio 2019. So that's interesting. All right, we are at the end of this presentation. Hopefully it was helpful for you, and hopefully you liked what you saw. I want to point that you can get access to the slides for this presentation here by using the QR code or the link which is here on the side. You should see it now. And at this address, you will find also a link to the repo, which is containing the code that I showed you in the demo. And so you can try things out by yourself. I recommend that if you want to try things out by yourself, first of all, you can do a fork of the repo. And then after that, you can once you have the fork, you can try to deploy that to a trial version, for example, to a trial account on Azure, and then start making changes, for example, in Visual Studio Code or in Visual Studio, save that, commit that to GitHub, and then you will see your changes being published as you go. It's really a neat way to do client-server application, all self-contained, and try to explore also Azure Static Web App, because those are really loaded with surprises such as role management, security, etc., etc. etc., custom domains, and all kinds of things. So this is super interesting. All right, hopefully this was helpful for you. My name is Laurent Bugnion. You can contact me here at Bugnion on pretty much every social. If you go on Twitter, my DMs are open, and so don't hesitate to send me a message. Thank you so much for your attention and have a great day. I will stay on for the question, so don't hesitate to ask questions if you have some. Thank you.